Welcome to Tranquil Sea of Math. Okay, we are given a quadrilateral with a diagonal interior to the quadrilateral. With this diagram, we have these givens that's going to tell us something about the geometry that's established. We have that OJK, and EKJ are going to be congruent to each other. And we also have that OK and EK are perpendicular to each other. So I've put in my corresponding congruent marks here, or my right angle indicator here, and I've also noted my givens. I've also showed some dotted lines here showing that we can extend the sides of not just our quadrilateral, but also the diagonal in here. And if we extend those sides, what we find out is that this is a line, this is a line, this is a line, this can be a line. Any of these can be lines. These are just segments of lines. And if we look specifically at the diagonal interior to the quadrilateral, if we expand that out, this is a transversal of these two sides. So I want to go ahead and make a note of that. So JK is a transversal. And that is by definition of transversal. And since we have these angles here that are alternate interior angles, we are going to use the converse of corresponding angles postulate to establish that these two sides on this parallel of this quadrilateral are going to be parallel. So we're saying that line OJ is parallel to line EK, and that's by the converse of the corresponding angles postulate. Okay, so this and this are parallel. I'm going to put some arrows here just to show that those are parallel. Now, since these are parallel and I have a right angle here, that means that this also has to be a right angle by the perpendicular transversal theorem. So we have that OJ is perpendicular to OK. And now I'm just going to switch these lines to segments. And that is definition of line segment. And at that point, we have proven what we intended to prove, so you can end this proof. Cheerful Calculations.